All right. So today we're going to be talking about something called sine, cosine, and tangent. These are called trigonometric ratios, and they work for right triangles. So it's a way that we can relate the angles on a right triangle with the sides on a right triangle. So, and not just with special right triangles, but with any right triangle. So yesterday and the day before, we talked about special right triangles, the 30, 60, 90, the 45, 45, 90. And those are great, but not every right triangle is like that. And so this is what we can do and kind of how we can solve for missing sides and angles and things like that. If you don't have a special right triangle, if you have just any old right triangle. So today we're going to introduce just the sine, cosine, and tangent ratios. We'll talk about what they are. And we'll also talk about how we can find them using a calculator, because you might have noticed these buttons on your calculator before that say like, it looks like sin, cos, and tan. But these stand for sine, cosine, and tangent. And so we're going to use those. We'll talk about what that does and everything. We'll also talk about how you would find those ratios just using a triangle with all the sides labeled. So with that, here we go. First, sine. So if you're looking at an angle, like let's take angle A. And if you want to label this, the sides, the hypotenuse is always the same, right? It's still across from the right angle. But you know, yesterday and the day before, when we referred to the other sides, we called them legs, right? And we had like the long leg and the short leg and stuff like that. But now that we're relating them to the angles, we have to talk about them from the angles perspective. So for angle A, the opposite side is side BC right here because it's across from it. It's not touching angle A. So this would be the opposite side. And I'm just going to abbreviate it as OPP. Usually for hypotenuse, we'll also abbreviate it HYP. So that's the opposite side to angle A. And sine is the ratio of the opposite side, the length, divided by the hypotenuse length. So we know sine, we'll just leave it as equals opposite over hypotenuse. Or sometimes you'll see again with the abbreviation OPP over HYP is what we're going to use from here on out. All right. So you take the length of the opposite divided by the length of the hypotenuse. Also, if you were to spell out the word sine, it would be S-I-N-E. But usually we just see it abbreviated like this, but it's pronounced like this. It's not sin, it's sine. All right. So then cosine. So the other side that we haven't talked about yet, this one, AC right here, if we relate it from angle A's perspective, this would be what we call the adjacent side. So it's the side that's next to angle A, but is not the hypotenuse. So this would be adjacent, and we just abbreviate that ADJ. So for cosine, we have adjacent over hypotenuse, or ADJ over HYP. And same thing with cosine. If you spell it all the way out, it's spelled like this and it's pronounced like this, but it is usually abbreviated as COS or cos, but we usually call it cosine, the full name, when we're talking about it. All right. So that would be the cosine ratio. And then the last ratio is tangent, which is the opposite over the adjacent. So it's the combination we haven't yet talked about. We talked about opposite and hypotenuse. We talked about adjacent and hypotenuse. Now we have to talk about this ratio. Opposite over adjacent, or OPP over ADJ. And just like sine and cosine, tangent is also abbreviated as tan, but we usually say the full name when we're talking about it, tangent. And it's spelled like that. Okay, so you might have noticed this SOH, CAH, and TOA written right here. It's a way that we can help ourselves remember which ratio is which. This stands for sine is opposite over hypotenuse, or cosine is adjacent over hypotenuse, or tangent is opposite over adjacent. And so a lot of people like to say SOHCAHTOA or SOHCAHTOA to kind of help themselves remember the acronyms. So that's something that we can kind of use to help ourselves get used to and remember which one's which. Okay, so here's how we would actually find those ratios down here, because we're going to have actual numbers associated with them. So I'm going to redraw this triangle over here on the right-hand side. I'm going to put angles A, B, and C out there. We've got our right angle. And then I'm going to put some side lengths on, because our goal is to be able to figure out these ratios given the side lengths. Okay. So take a moment, draw this if you haven't. And then we're going to talk about what these ratios are. So when we talk about sine, we're talking about sine with respect to an angle. So in this case, we're talking about sine with respect to angle A, which means when I go and label my sides, I want to label them from the perspective of angle A. So this is angle A right here. Across from angle A is the opposite side. So OPP is what I'm going to put there, just so that I remember that's what goes with angle A. And then the hypotenuse is always across from the right angle, and the hypotenuse never changes. It's always that across from the right angle side. And then the only one that's left, the one that's next to angle A but is not the hypotenuse, is the adjacent side. So I'll put ADJ right there. So now I have all my sides labeled from the perspective of angle A. So now all I have to do is go, okay, sine was opposite over hypotenuse, right? That was up there, yep, opposite over hypotenuse. So I take the length of the opposite side, which was 4, and I put it in a fraction over the hypotenuse, which was 5. That's the sine of angle A, 4 over 5. And that's the answer. Or cosine of A. Well, that would be adjacent over hypotenuse. So I go find my adjacent side, which was 3. And the hypotenuse was still 5. So 3 over 5 would be the cosine of A. And then lastly, we want the tangent of A. It's the opposite over the adjacent. So I go over to my triangle and I go opposite was 4. Adjacent is 3. 4 over 3. And that's all we got to do for sine, cosine, and tangent of angle A. And remember, that's all from the perspective of angle A. So we can also do this from the perspective of angle B, the other angle. The other angle that's not a right angle, I should say. So if I want to do things from the perspective of angle B instead, I have to relabel my sides. So we look at angle B, because the opposite of angle B is not this side right here. It's actually over here. This would be the opposite for angle B. So in red, I'm going to label opposite for angle B is actually 3. The hypotenuse always stays the same. So this 5 is still the hypotenuse for B. It's still across from that right angle. But the adjacent for B is 4. So we might notice that the only thing that changes is if you're going for the perspective of the other angle, the opposite and the adjacent trade places. Other than that, it's all the same. So we're going to go and find sine of angle B, cosine of angle B, and tangent of angle B. So now we're looking from the perspective of angle B, but we still want the same thing, opposite over hypotenuse for angle B. Well, angle B's opposite is 3, so 3 would go on top. The hypotenuse is still 5, so 5 goes on the bottom. Then for cosine of B, same kind of thing. We want adjacent over hypotenuse still, but the adjacent for B was 4, so 4 is going to go on the top. The hypotenuse is still 5, so 5 goes on the bottom. And then lastly, for tangent of angle B, still opposite over adjacent, but the opposite for B was 3, so 3 goes on top. and the adjacent for B was 4. So 4 goes on the bottom. So now we have sine of B, cosine of B, and tangent of B. You might go, what the heck are these ratios for? That's going to come in due time tomorrow. And then next week, we're going to go over how would I use these to actually solve for something in a triangle. But for now, we're just going to practice writing those ratios and getting good at that, identifying the opposite side, identifying the adjacent, identifying the hypotenuse. So a couple of things before we move on that you might notice here. Look at the sine of A and the cosine of B. Those are the same. In fact, then the cosine of A and the sine of B are the same. They just trade places when you go from the perspective of one angle to the perspective of the other. Also, tangent just flips the fraction when you go from one angle to the other angle. So that's another kind of thing we can notice and a way we can work with these. If you have the tangent of one, if you want the tangent of the other one, just flip the fraction. So that's kind of cool. All right, so that's sine, cosine, and tangent and finding their ratios. We'll practice one of those, or we'll have you guys practice one of those in just a moment. The other thing that I do want to talk about is if you're given an angle and a calculator, because you can type all of these things into a calculator. So if you know an angle measure of 35 and you want to know what is the sine ratio for that angle, it's going to give you a decimal, and that's okay. But we're going to plug this into a calculator and see what we get. So here's how this works. Grab your calculator, and usually it's this row right here that has sine, cosine, and tangent on most scientific calculators. Desmos has it as well if you want to use Desmos on your Chromebook. You can also do it on your cell phone, but if you're using the regular iPhone calculator, this is where we start not recommending doing that because it's a lot harder to keep track of your equations. So from this point forward, if you're going to use a calculator on your cell phone, please download a different calculator app, not the iPhone one. Okay. It'll help yourself cut down on errors and things like that. But here we go. If I want to know sine of 35 degrees, first I check that my calculator's in degree mode. Notice how RAD is highlighted. So if you hit mode and go to move it over to degree and hit enter, and then hit second quit, that'll get it into degree mode because we're dealing with degrees in geometry. Later on in advanced algebra trig and calculus and stuff like that, you'll get to use radians. But for now, we're just dealing with degrees. So if I type sine and then type 35, since that's how many degrees my angle is, and I hit enter, it will give me a decimal value for sine of 35. So now my answer is just 0. If I was going to round this to 3 decimal places, which I recommend doing at this point, the 5 here on the 4th decimal place tells me to round the 3 up to a 4. So 0.574 would be my answer. And that's all you have to do. So let's try another one. What if I type cosine 47, enter? All right, the 9 tells me to round the 1 up to a 2. So 0.682 would be my answer. All right, simple as that. Let's try tangent now. Tangent of 67, enter. All right, here the 8 tells me to round the 5 up to a 6. So 2.356 would be my answer there. All right, so that's as simple as it is with the calculator. And this is something we're going to keep using more and more, especially as we go through tomorrow to solve for missing sides and things like that. So I know it seems simple, but we're doing it for a reason. We're doing it so we can use it tomorrow. We got to practice it today. All right. At this point, I'm going to give you a couple to try here. So go ahead and draw a triangle. And we'll call this angle Q, angle P, angle S. And I'm going to say this side is 5, this side is 12, and this side is 13. So from this, I would like to know, what is the sine of P. I would also like to know what is the sine of Q. And what is the tangent of P? The second thing I would like you to do that's not related to this triangle is tell me what is the cosine of 74 degrees. Okay, so pause the video here, give this a try, and then let the video keep going, and we'll figure out the answers. All right, so hopefully you paused the video and figured out the answers, and now you're coming back to check your answers. So here we go, checking answers. Sine of P. Here is angle P. All right, so I want to label with respect to angle P. So the hypotenuse would be 13. It's across from the right angle. The opposite would be 12. I'm just going to put an O there for it. The adjacent would be 5 for angle P. So sine is opposite over hypotenuse. So opposite and hypotenuse are 12 and 13. So 12 over 13. While we're at it and we're in this mode and we've got things labeled with respect to angle P, I'm also going to find tangent of angle P real quick. Tangent of angle P is opposite over adjacent. And the opposite is 12 and the adjacent is 5. So for tangent of angle P, we should get 12 over 5. All right. So now we've taken care of both of the ones I wanted to know about angle P. Now we're going to go to angle Q. And I'm going to label things with respect to angle Q. So the opposite for angle Q is going to be 5 because the opposite and the adjacent switch places. So the adjacent is going to be 12 now. And the hypotenuse is still the same. So sine of Q is opposite over hypotenuse. So this time it's the opposite is 5. The hypotenuse is still 13. So 5 over 13 for sine of Q. All right. So that's the first one. The second one, cosine of 74. So I'm going to grab my calculator again and type cosine 74, enter. And we get 0.2756. The 6 tells me to round the 5 up to a 6. So 0.276 would be my answer. All right. So that's sine, cosine, and tangent, kind of our introduction to that. Tomorrow we'll go over how do we actually use these to solve something. But for today, your homework assignment, if you turn the page, we have this page where you're finding sine of C and sine of A, or cosine of C and cosine of A, depending on what it's asking for. So it's got all the sides labeled. You label them opposite, adjacent, hypotenuse with respect to whatever angle you're working with, and find those ratios. It might be a good idea at the top to write, like sine is opposite over hypotenuse and stuff like that, and cosine is adjacent over hypotenuse, so that you don't have to keep flipping back and forth. But you can always flip back to your notes if you need to. Then the other page, if you turn it, find the value of each trigonometric ratio to the nearest 10,000th. I'm just going to actually make it to the nearest 1,000th, cross off the 10. We're just going to go to 3 decimal places. All right. So find the value of each trigonometric ratio to the nearest 1,000th, 3 decimal places. So this is the kind where you're just typing it into the calculator and putting down your answer rounded to 3 places. All right. I'll be back tomorrow. So if you have questions, feel free to ask, or feel free to email if it's something urgent. Otherwise, have a wonderful rest of your day and get that homework done. See you tomorrow.